The plan for this lesson is to give an introduction to data mining. We will start with the motivation and why data mining is needed, then go over a formal definition and discuss what goes into the process. Let's start with a motivational example. This illustration shows the data collected during World War II. As you can see, bullet holes were on the planes that returned from the front. The British gave the data to Abram Wald and asked him where to put more armor on these planes. So, what do you think? At the first glance, one would think that more armor is needed wherever bullet holes were observed, right? Because after all, these are the locations where the airplanes got hit. But if we pay attention and listen to the description of how the data was collected, then one would quickly realize that these are the planes that returned. So these planes sustained these hits. And maybe it makes more sense to protect the areas where there were no bullet holes observed. And this is a great example to show how knowledge discovery has been there way long ago. Why data mining? Over the past 20 years or even more, we have been collecting more data from the technology that we have developed. Think about networks, wireless networks, sensors, Internet of Things devices, and at the same time, we've been making a great progress in high-speed computing and storage. So now, leveraging data and computing together to find useful patterns and insights inside the data has become something very natural to do. And one can find applications in business, science, society, environments. So in other words, wherever there is data, there is a problem formulation that we are going to try to solve. What is data mining? It's the process of extracting interesting, non-trivial, implicit, previously unknown, and potentially useful patterns or knowledge from huge amounts of data. Let's break down the definition. So, interesting, non-trivial, and surprising is something that we're going to be surprised to learn, like the story of the bullet holes on the airplanes. Who would have predicted that more armor needed wherever there were no bullet holes observed? So data mining uncovers information that was previously unknown. This is a new knowledge. But once this knowledge is discovered, it can be applied in different domains. One more thing I should say here is data mining as a term is a misnomer. It would have been more expressive to say knowledge discovery from the data, but this is how the term was coined and adapted. Now we are at the point where we want to differentiate between what is a data mining task and what is not. Anything that has to do with search or query processing, this is not a data mining task. It's true, there's a large amount of data that is somehow indexed and ranked, but simple search, query processing is not data mining task. Not long ago, research on deductive or expert systems used to be very popular. And what we try to do there is to prove propositions and theorems using deductive and expert system. But again, this is not a data mining task. So data mining is the process of uncovering interesting, non-trivial, something we have yet to think about from the data, and not rules or search. Knowledge discovery from data is a process. This pipeline shows the main components of knowledge discovery. Starting from the left, Some data has been collected, but we don't directly go and analyze it because of its size. It's a very huge amount of data. And at the same time, there's going to be data quality issues that need to be addressed first. The next step is data pre-processing and selection, which means data should be prepared in a particular form so it can be fed to the next analysis phase. Some of pre-processing tasks could be sampling, computing summaries. Selection tasks could be feature selection or feature creation. So everything in this phase depends on the requirements of the analysis tools that we are going to use. Now that our data is in the proper form, we can go ahead and perform the analysis. Sometimes this means running a data mining algorithm, or running a statistical analysis tool, or another machine learning algorithm. So all it's going to depend on the problem that we are trying to solve. The result of the analysis is going to be a pattern, a model that we need to validate. And we're going to learn a number of methods to do the validation based on the data that we have. And sometimes things work out great from the first time, but this is very unlikely. That's why we have those feedback arrows to go to previous steps, maybe collect more data. So it's not just a single linear path that takes us from start to end. Very often we have to loop and iterate. Again, this is the same KDD process that we just explained, but illustrated in a more abstract form to focus on pre-processing, analysis, and post-processing. In summary, data mining is the process of discovering interesting patterns and knowledge from the data. It's a natural evolution of science and information technology with many applications, and the KDD process includes data pre-processing, data mining, and post-processing.